Okay, sorry about that. Not a great start. Okay. Um, Hi, well, thank you for the opportunity to present on this. I'm going to talk about a project which is being run by the Confederation of Open Access Repositories that I act as a consultant to, technical consultant. So I'm going to try and give a rapid overview of what we're doing and give you an idea of the sort of direction we're going. There's unfortunately, I've received information today that it looks like we have received some very significant funding for this, but I'm not allowed to talk about it today, which is a pity. But you should hear about this fairly soon if you're interested in following this. So, okay, I'm going to give a quick context to what this project is really about. So, we're sort of happy to have a globally distributed network of repositories, and this has come about through almost by accident in some respects. The sort of institutional open access repositories and the peer review, the preprint repositories which we have growing up now, and people moving into data repositories and so on. And all of this is quite naturally resistant to the sort of monopolistic capture and control that we've tended to see in scholarly communications in particular, and some of the domains that we work in. So that's an important point to make, I think, by way of context. And then the other thing is we have the web and all of the open standards, which are now quite mature. And a lot of these open standards, which some of which I'm going to talk about, are important, not just because they're open and mature, but because they're also mainstream. One of the weaknesses of some of the domains that we work in the past, I'm thinking about the sort of things which we used to call the digital library space a while ago, was we tended to invent new protocols and standards and technologies which were never mainstream. But actually, we now have a range of mainstream standards we can use, and we don't need to go down that road. So there's an opportunity which we see, which is that the perceived importance of repository content seems to be growing. Preprints are becoming more important again, and this is great news for a number of open access initiatives. We have a growing number of data repositories and other content types, and we're starting to see services appear which are aiming to exploit that open access repository content in a good way. So that's the context really. There are some some principles behind the project which I want to just go into quickly. So we're really interested in not so much in connecting and integrating repository systems, so much as integrating the resources in the repositories with resources elsewhere. So this is taking a what's called a resource-oriented view of the world, which is natively supported by the web and all of the web technologies anyway. In programming, we have this notion of passing by reference or passing by copy, where you either shift information around en masse or you pass pointers to that information. And the web allows us to pass by reference by essentially using URLs for everything. So what we're interested in doing is connecting up resources in repositories with resources in other systems or other repositories even, by linking those URLs together, creating bidirectional links. We want to take advantage of the distributed network of systems, nonetheless, and that reduces or maybe even removes our reliance on centralized services. And finally, we want a general solution. So one of the other problems with I've been working in and around repositories for quite a long time now, and I've seen a lot of projects come and go where the technologies are interesting, but there's a significant cost to maintaining things. Each time a new integration or a new API becomes attractive to repositories, there needs to be more development to support those APIs. What we're looking for is something which can be reusable. Repositories tend to exist in a fairly low resource conditions often, and there isn't a lot of money or time or available effort to keep developing solutions. So something which can be highly reusable is a very attractive thing to us. So the technical approach which we've selected is to use two available W3C standards. So the first and the sort of fundamental one is linked data notifications, which is a very simple protocol supporting asynchronous messaging between systems. So it has this sort of logical structure in that diagram in the middle of the slide there, where systems have an inbox, they can receive notifications, or they have access to an inbox, sorry, they can receive notifications in that inbox, and then they can consume them and do something with those notifications. And similarly, they can send notifications. I'll talk about the makeup of those notifications in a second. But the other important standard to refer to here is called Activity Streams 2, which is essentially a vocabulary for describing interactions on the web between agents and resources. And we have found that it pretty much supports the use cases that we have with some minor additions. So we're very much relying on that. So I'm going to talk about, go through an example use case very rapidly, just to give you a sense of what we're trying to achieve. So if you imagine that you have a repository and a peer review service, and we're just going to map out a very simple use of notifications to enable peer review. So the repository has a preprint in it. That's the little green box there. And the preprint has a URL, which is URIP, we're calling it there. Both the repository and the peer review service have implemented W3C's linked data notifications, so that each of them has access to an inbox for receiving notifications and an ability to send them. So you'll see those two little boxes on each service. So the first thing that happens is the repository sends a notification to the peer review service requesting a review. So it sends a very simple payload. I can show you an example of that in a moment. But crucially, it includes the URL to the preprints that it's asking to be reviewed. That's sent as a notification, a linked data notification, to the peer review services inbox. And the peer review service does whatever it needs to do to decide whether or not it wants to attempt to review that preprint. There's some discussion there. All of that is out of scope of our project. Whatever mechanism or procedure is needed to happen there happens. And in this case, the peer review service decides that it will initiate a review of this resource. So it sends an acknowledgement back to the repository saying that it has agreed that it will initiate a review. So the repository at that point can do whatever it wants to do. One thing it might wish to do is to label that resource as being under review, perhaps to stop the resource from being added to another review service in the meantime, pending the current review. It might want to indicate this is happening to users of the repository resource. It might wish to communicate this to the author, perhaps. It's up to the repository. Again, this is out of scope for our project. What we're trying to do is enable the messaging between the systems. So time passes and the review service organizes a review, and eventually a peer review is created. That's the blue box on the right there, and you'll see that also has a URL, so that's URIR. And having created that, the peer review service uses the notify protocol to announce that review together with the URI to that review back to the repository. So that goes to the repository's inbox. And then the final stage is that the repository is then able to update its records, do whatever it wants to do to indicate to users that this has been reviewed. And crucially, it now has a URL to a review that it can include on its splash page or in the metadata for that item. And the peer review service obviously has a link to the thing which it has reviewed alongside its review. So these two are now linked to each other, these two resources within these services. Okay, so we'll have a quick look at some patterns to give a sense of the sort of payloads which are sent around in these notifications. So the payloads are RDF, that's a requirement of the linked data notification standards. It doesn't specify which serialization format is required, but JSON LD seems to be the accepted norm now for this. And indeed, all of the examples that are given of activity streams to payloads are in JSON LD. The idea really is that there's very little metadata is sent between systems. The idea is to keep that as minimal as possible. The point really is to pass by reference, so that if people want to get access to rich metadata, then what they can do is follow the reference back to the source, back to the system which has that metadata. So you'll see on the right, there is an example of a payload, and that's the entire payload, and it's essentially a series of URLs. I'm not going to go into each of the different parts of that in detail, because I won't have time to do that in this talk, but it's all well documented, and I can give you the link to the documentation. We've added very little to the on top of activity streams too, and in fact, the snippet of JSON LD code on the left underneath the bullet points, that is the entirety of what we've added so far. Okay, so everything else is in mainstream standards vocabularies. We've defined some patterns, some reusable patterns, and we've defined a number of these patterns. So things like requests and acknowledgements and announcements of things. And these again are completely documented in this form. So you'll get an example JSON payload for each pattern, and an explanation of what those properties refer to. The kinds of properties which are included are all defined in activity streams too, but they're things like the origin and target describe the two systems which are engaged in this communication. We have an actor, which is sometimes a service, but can also be a person if a notification exchange is initiated by an author, for example, then that could actually be a person. We have a number of IDs of different resources, and we have some fairly thorough ways of describing resources to allow for things like multiple identifiers for things such as typically in repositories we might have a metadata page and a canonical URL for citation, a DOI, something like that, possibly even a file URL to get directly to a PDF for a preprint, that kind of thing. So we have ways of encoding all of these in a standard way. Another thing that's worth noting there is that it's possible to have an in reply to. So this is a way in which the notifications themselves are linked together. So this notification is in reply to a previous offer. This is how the various systems involved can track the transaction, if you like. We've also found a way of mapping out scenarios. So this is quite similar to the use case I went through earlier, but this is laid out in a form which allows you to inspect the documentation. So this is using the kind of swim lanes approach from process modeling. So there's a system on the left, a system on the right. The notifications are in the middle, and each of those is a step, each notification, and you can drill down into those to see the actual properties which are being exchanged and so on. And we have about 10 or 12 of these we've documented so far. A quick note on the supporting infrastructure. So we've got the documentation which I've just described. So that's all openly available. And we've also developed some test inboxes, so that there's a place for people who are just beginning development with this to be able to send notifications and see the results. It's fairly lightweight sort of test infrastructure, but it's been somewhat useful to some of the participants so far. A very quick word on implementations. So far we have several active developments. So DSpace 5 and 6, there's been a platform development there to working in conjunction with a national research organization in Portugal to enable notify between the DSpace repositories and I believe it's a kind of reporting system in Portugal. Dataverse, so Harvard University are working with Dataverse to implement notify communications between a Dataverse data repository and their main university publications repository. So this is linking a publication to a data set, for example. And HAL is the national level repository in France. And so HAL have integrated with the other two systems listed there, Peer Community In, which is a peer review, open peer review system, and EpiScience, which is an overlay journal. And then we have other people who are considering development and have been involved in the project but haven't started development yet. So in Venio, we're talking to, and people at Zenodo specifically. DSpace 7, I believe, is definitely going to go ahead because Harvard have an interest in that too. And we're actively talking to Humanities Commons, which be an interesting use case involving Fedora and WordPress, I believe. Some other systems that have talked to us and are very interested, I think, are kind of waiting to see how we progress before they commit, but I think they probably will. Our pre-review, which is a peer review service, and eLife have a system called Society, which is a kind of aggregation of information about events which have happened in scholarly publishing, such as something being published or a review being made or something like that. So my plea to the community is, can we involve Samvera and Hyrax in this? And that's really all I have to say, and I've managed to land it bang on the hour, so I'm quite happy with that. Please go ahead and email me if you're interested in finding more.
Thank you so much, Paul. I hope this is a beginning of a conversation so that we can be in touch. Thank you everyone for joining us today. I hope you'll join us tomorrow. We'll have another day of great updates and information and same time. So thank you very much. Enjoy the rest of your day.
Thank you.